Welcome back, everyone. We're looking at Chapter 2, comparing two proportions today. Okay, and the objectives for today are all around testing a difference in proportions. So I would like, by the end of this lesson, for you to be able to calculate the test statistic, to explain how to use note cards to simulate the distribution of the test statistic, and to be able to use a dot plot to estimate, interpret, and make appropriate conclusions from the p-value. So a few things to remember from our last lesson, okay? Hypotheses are always stated in terms of ability. Okay, your null hypothesis will always claim equality. Your alternative hypothesis will either claim an inequality or a non-equality, right? In this case, it's either going to be greater than or less than. And your alternative hypothesis is what we expect to be true. Okay, it's what we're hoping to show that is true. And to do that, we have to use a hypothesis test. Okay, and that's that formal process used to determine if we have the convincing evidence to support that alternative hypothesis. So if you go back to our hypothesis that we wrote about the 2019 Vikings, okay, we said that the 2019 Vikings have the same ability to win at home and on the road was our null hypothesis. Okay, and our alternative hypothesis was that the 2019 Vikings have a greater ability to win at home than on the road. And if you don't remember, our data is presented right here. Okay, they were 6-2. Okay, so 6 out of 8 games they won at home, and they were 4-4. So they had 4 wins out of 8 total games on the road, which gave them a 10-6 overall season. 10 wins, 6 losses. Okay, so in looking at the test statistic, right, that is a calculated difference, okay, from the performances that we're going to use as evidence in our hypothesis test. Okay, so in this chapter, we're going to use the difference in proportions as that test statistic. Okay, so if we go back, right, they won 6 out of 10 or 6 out of 8 at home, or 75%. They won 4 out of 8 on the road, or 50%. So the difference in proportions, right, we subtract them. 75% minus 50% gives us a test statistic of 25%. Okay, so we'll be testing to see how likely is it for a team that goes 10-6 overall to have a difference in performance at home and on the road of at least 25% due to random chance, right? Because we have to assume the null that there is no difference. Okay, so we want to see, right, 25%, at least 25%. How many times are we more than that, right? So to do this, right, we're going to run a simulation. Okay, so would we be able to use a spinner to do this? Well, how would we set up our spinner, right? That's the problem, right? We can't because we don't have that assumed ability, which means, right, that we have to use a different type of simulation. Okay, so we're going to go to a note card simulation. Okay, so we can determine, okay, points to find out whether or not, right, the test statistic holds. So we're going to start off with 16 equally sized note cards. Okay, on those 16 note cards, on 10 of them, we're going to put a W for win. On 6 of them, we're going to put an L for loss. Okay, then we're going to flip them all over so they're all W and L down. We're going to shuffle those cards together. Okay, we're going to then put them into 2 equal piles of 8. Okay, to simulate their 8 home games and their 8 away games. Okay, so I did this right here at home. And when I did this, okay, I came up, when I flipped my cards over for home, I got W, 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 L, 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 W, W. So that's 5 wins, that's 3 losses for a winning percentage of 62.5%. Now, for the road, I got W, L, L, W, 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 L. So that means I have 5 wins and 3 losses. So here you can see, right, I had a 62.5% win percentage at both home and away. So that this one simulation's difference was 0%. Okay, a little different than the 25% that we actually saw. Now you should be able to see here, right? It is possible to get a negative difference because if, I flip these over and I get, that we're 2-8 at home, okay, and then or 2 out of 8 at home, and then we went 8 out of 8 on the road, right? I won more games on the road. Okay, so it's possible to end up with that negative. Okay, so instead of making you do this 100 times, right, we're going to run simulations. So I put this into the program, which I'll show you how to use later, okay, and ran 100 simulated seasons just to see what would happen. Okay, and when I did, these were the results that I got. Okay, and as always, I dropped my line here, like we talked about in chapter 1, right here, right, that shows where my test statistic fell, right? So we're looking at from here and everything over. Okay, so from the simulation, does it look like we have convincing evidence to state that the Vikings' ability was greater to win at home than on the road? Well, 29 of those dots, right, are at or above the 0.25 or a 25% difference. So that means that 29 out of 100 or 29% of their simulations produced that difference, right, of greater than or equal to the actual difference of 25. Okay, so that's what we call our p-value, that 0.29. Okay, so what's the probability of getting a test statistic, right, that's at least as extreme as the observed test statistic? Well, according to our null hypothesis, right, we can't state that it makes that difference, right? Because that result of the simulation provides that estimated p-value, which we know 0.29 is quite large. Okay, so when we make a conclusion about this, right, there are two possible conclusions we can reach. We can either reach the fact that we're going to reject our null hypothesis or that we're going to fail to reject our null hypothesis. Okay, and the p-value is what gives us that information we need about the null hypothesis to reach a conclusion. If the p-value is small, right, we'll reject the null hypothesis. If the p-value is large, we will fail to reject the null hypothesis. So what would be considered a small p-value? I'm glad you asked, Brick. Right? If you remember back, we talked about this in chapter 1, right? That p-value that we're looking for, that significant level, right, is predetermined ahead of time, right, of what it should be. And what we said for this class, we would always use 5%. Now, it is possible to change that up and use different p-values. Okay, you could use values such as 1% or 10%, but it's always a predetermined amount. Okay, so if our real p-value is smaller, right, it's less than that, right, then we consider that a significant level. Okay, that significance level can be denoted with alpha, okay, which is a Greek letter. So if we revisit those two possible outcomes and we look at them in terms of p-value, okay, if the p-value is less than 0.05, then we reject the null hypothesis because this means that random chance is not a plausible explanation. Okay, therefore, we have convincing evidence to support that alternative hypothesis. If the p-value is greater than or equal to that 0.05, then we have to fail to reject the null hypothesis because that means that random chance is a plausible explanation. So therefore, we do not have convincing evidence to support the alternative hypothesis. So that means the smaller the p-value, the more convincing our evidence is. Okay, so if our p-value is 0.02, right, or 0.002, okay, that would be more convincing than a p-value of 0.03, because that would mean, right, the first one of 0.002 is a 0.2% chance that it's random chance that caused it to happen. Whereas a p-value of 0.03 means that there's a 3% chance that it's by random chance. Okay, so if you're struggling to remember it, a little thing to help you, just remember, if p is low, the null must go. Okay, when writing a conclusion, there are three parts we need to make sure that we include. The first one is the comparison between the p-value and the significance level that's set, right? And remember, we're always going to set a significance level of 0.05 or 5%. Okay, a decision whether you're going to reject the null hypothesis or fail to reject the null hypothesis is the second part. And then the final part to every conclusion needs to be a statement where you either have convincing evidence to support the alternative hypothesis, or you don't have convincing evidence to support the alternative hypothesis. So go back to that initial hypothesis again, right? The 2019 Vikings have the same ability to win on the road was our null hypothesis, and that they have a greater ability to win at home than on the road, right, was our alternative hypothesis. Okay, the p-value in this simulation was 29%. Okay, clearly that's too big. So remember, there are the three parts that we have to include in our conclusion. So we have, because the p-value of 0.29 is greater than the significance level of 0.05, first one, we fail to reject the null hypothesis, second part. And then we do not have convincing evidence to support the claim that the 2019 Vikings had a greater ability to win at home than on the road, the third part. So there, our conclusion very clearly states the three parts that are needed for a valid conclusion. So, as I promised earlier, I will show you how to use technology for this simulation. Okay, because index cards, they might be fun to do one time, but it's rather time consuming to run 100 simulations. And in this case, we're only talking about 16 games. If we talk a major league season, now we're looking at 162 note cards shuffled out each time. It's just too much. Okay, so in fact, let's use the 2019 Astros. Okay, this is a pretty hot topic right now around the sports world. Okay, they went 60 and 21 at home, so 60 wins, 21 losses. They went 47 and 34 on the road, so 47 wins and 34 losses. They went, for the season, 107 wins to 55 losses. Okay, clearly, I don't want to make note cards for this. So first of all, let's write our hypothesis, right? Our null hypothesis has to be that they're the same. So the 2019 Astros have the same ability to win at home and on the road. Your alternative, right, is that the 2019 Astros have a greater ability to win at home than on the road. So steps to simulate a difference in proportions by using technology. Okay, so this applet that I will put a link to, okay, in the Schoology folder, okay, that's the one that we're going to use. Okay, it also is linked here in my PowerPoint presentation. Now, this following information I'm going to put up here. Then we'll actually go to the app and you'll see exactly how it works. Okay, so what we're going to do is, in our context success, right, we had 60 games out of 81 for home. We had 47 wins out of 81 games on the road. Okay, and then we're going to calculate the observed difference, and then we're going to run 100 trials. And then, just like before, we're going to put in the observed difference and click count to see how many times this happens. Alrighty, took me a minute to get here. So right here for success, okay, we're going to put in 60. Total attempts are 81. Context 2, we said we're going to put in 47 successes out of 81 attempts. We'll now calculate our observed distance or difference in proportions, or our test statistic, which is 0.10. Okay, we want to simulate this season 100 times and see when that would happen. So we're going to add more trials. Okay, here's our dot plot results. Down at the bottom, we want to count the number of dots, right, that are greater than or equal to our test statistic. So 0.16. And then we're going to click on count. So in this particular case, you can see it says that there are 98 dots that are less than, oops, I forgot to change it to greater than. I'm sorry, guys. So change it to greater than and then click count. Okay, and there are 3 dots, okay, are greater than or equal to the specific value. Okay, so we have these 3 little dots out here. So that would mean a 3 out of 100, right? So that would be 3%, which is less than our 5%. Now, for the remainder of this PowerPoint, you're going to see that I'm going to use the test statistic or the statistics that I got when I ran this last time. Okay, so we'll go back. So the data that I got when I ran it last time looked like this. So similar, but not exactly the same, right? And it will be different. Okay, that test statistic or observed difference in this case, okay, had a p-value of just 1 because only 1 out of 100 times was it greater than that. Okay, so that means we can make a good conclusion from that. Okay, so we can conclude, right, that because the p-value of 0.01 is less than that significance level of 0.05. Okay, so that's the first part, that we can reject the null hypothesis. That's the second part of our conclusion. And the third part, that means that we have convincing evidence to support the claim that the 2019 Houston Astros have a greater ability to win at home than on the road. Now, we do have to be careful of something called causation. Okay, there are many things that can contribute to home field advantage. Whether you're talking about the fans, the comfort level of the players in their own houses or their normal, sleeping quarters, the familiarity with the field, there are all kinds of things. When talking the Astros, there's the whole sign stealing that we would have to look at also. But under these conditions, right, it's impossible to tell exactly which one of those variables truly gives the home field advantage. Okay, I know a lot of you want to claim that it's the sign stealing, but with this particular, look into this data, we can't do that. Okay, it's impossible to tell, and so we call this we say that the variables are confounding. Okay, yes, we know that there's a difference, but it's confounding. We can't say specifically what the cause is. Okay, so that convincing evidence exists. Yes, home field advantage was there, but no, we can't say why. So looking back at the two pieces of data or the two sets of data that we just looked at, right? It might be a little odd, right? In the fact that the Minnesota Vikings test statistic was larger, 25%, right? Whereas the Houston Astros was only 16%, right? So it's smaller. So why in the world was it that the Vikings didn't show convincing evidence, but the Astros did? Okay, and the number of observations is why, that sample size. Okay, so remember, when sample size is increased, the effects of random chance are decreased, and the performance will be closer to the actual ability. Right, with the Minnesota Vikings, we only had 16 games to look at. The Houston Astros, we had 162 games to look at. Okay, so one of the most important concepts of this course, okay, is that there really is, if that really exists, a difference in ability. We are much more likely to find convincing evidence of that difference when we use a larger sample size.